You just did with matrices, you did simultaneous equations where we had an x and a y. So you had something as simple like, I don't know, oh, did we do it? Have I got it still here? How sad, I haven't. Thought I might. Oh, what a shame. Disappointing to say the least. Oh well. So we've had simultaneous equations that we were able to solve with matrices when previous years we used elimination or substitution, right? We've now got, instead of just x and y, we've now got x, y, z. And as you will see in problems coming up, they can be used just to solve various problems. So the x, the y, the z can represent, you know, I can remember some of the questions were mixed nuts, like peanuts, cashew nuts, and something else, Brazil nuts, and the cost and all that sort of stuff. So you can use it for that. In Year 12 spec, we use them to represent planes in 3D. Okay, and when we've got planes in 3D, and sorry for those playing at home, I have to stop at the moment. And what we want to do is we're going to write this as a matrix first. So have we written down the equations? We could do this like we did with the 2D where we had the AX, right? You could write it as a 3 by 3 matrix, so 1, 2, 1 and so on, and then instead of having XY going down, we could have XYZ. Problem with that is to get X by itself, we have to find the inverse of a 3 by 3 matrix, and that is a bit of a nightmare. So we don't want to do that. What we're going to use here is a thing called row operations. So we write this. This is what we call, and you don't need to write this if you don't want to, but we've got it in an augmented matrix form. God knows why it's called that. Don't care. And what we're going to try and do, right, we're going to work our way through by doing some row ops, and what we want to try and make it is that we will have the 1, 2, 1, we want to have a 0 here, whatever, whatever. We want to end up having a 0 and a 0 here, whatever, whatever. Okay, so that's the key, that's the goal, that we want to end up with the zeros there. And to do that, we're going to pretty much do what we did with simultaneous equations, but we have to note down what we do. So I'll stop talking and we'll just do it, because you will see in a minute it becomes quite easy. All right. If you have those 3 equations, the first thing is, because it's the first time they've given it to you, we've got a nice 1 at the top. If they had written this first equation, let's say they'd written it last, you are allowed to elevate it to the first one. So it's really handy. If one of your equations has a 1x, make that your first equation. And you'll see why in a minute. So we write this, we go 1, 2, 1, 3. And now what we want to do is we want to end up with a 0 here. So in order to do that, we are going to say 2 lots of row 1, 2 times this, so make that a 2. 2 times that minus row 2. Would you agree? And we must write this to the side. So I'm now going to do what I've just said I'm going to do. So I'm going to times this. I'm going to go 2, 4, 2, 6, right? Just times that through by 2. And I'm going to subtract row 2, 2 minus 1, 1, 8. Is that stuff over here in yellow, you know, part of the deal? Yes, I will take marks off if you don't include it, because it really helps for me as a marker to see what you're doing, and we are going to make errors. And you're going to have to go back and find out where your error is, because it's not difficult maths, let's face it. What's 2 take 2? 0. Huzzah. What's 4 take 1? 2 take 1 is 1. 6 take 8 is 2. So we can now pop that 0, 5, 1, 2. Negative 2? Of course it is. We're good? I'll do a little bit of colour coding just so you can see. And now, of course, we want to have a 0 here. So what are we going to do to make that a 0? 3 lots of, yep, take row 3. There's nothing wrong with you saying row 3, take 3 lots of row 1. I just always like to go top, take bottom. I don't care if I get negatives. So we'll write that down. I'm going to go 3, row 1 minus row 3. When we talk about do you have to show you're working over here, my preference is yes. If you're asking do you have to write this, these are the row operations, absolutely. You must write those row operations. They are essential. So here we go, 3 times row 1, 3, 6, 3, 9. And then we're taking away row 3. So we're taking 3 minus 4, 118. I'll give you a minute. Okay, next one. So we're going to go keep that row 1. That's just set. Row 2 is also now set. So we've got that 0 where we want it to be, so we're not going to touch it. And the other thing, Ollie, is that to get these row operations here, we always use row 1. Okay? Please do not go row 2 take, like 3 row 2 take 2 row 2 row 3. No. Now we can though. So in order for us to have a 0 and another 0 here, we have to at this point just use row 2 and row 3. Why can't we use row 1? Because it's got that 1 and that will lob back in and then we haven't got 0, 0. Okay? So how do we make this become a 0? Well, we're going to have to times row 2 by? What's a number that 5 and 10 both go into? 10. So we're going to go 2 row 2 minus row 3. Whee! So for some of these, you might go, I'm not going to rule a margin. Up to you. And do it to the side. You have a go, then I will pop it in. I chose the wrong one to do. Anyway, so with this, we now end up, and I chose poorly. If the last row was 0, let's go 5, 5. This is your x, this is your y, this is your z, right? So we would then say 5z has to equal 5. Therefore, z is 1. You would then put it back up to this one here, and you would go 5y plus 1z, but z is 1, so 1 times 1 is 1 equals minus 2, get rid of the plus 1, take 1, so on, get y. Once you've got y and now you've got z, you can pop it back in here, correct? We're covering all bases at the moment because that did not happen. We'll do one like that in a minute. I jumped the shark a bit, jumped the gun. In this case, what we have here is 0 times z equals 5. And now what's going on there? 0 times something equals 5. Is that possible? It is impossible, right? Not possible. So this means no solution. And for us, if we're talking about planes, Tristan, it would mean they do not meet in a unique solution. It could be that they meet along 2 lines. It could be that they are just not meeting at all. 2 lines, 2 coincident, 2 parallel are meeting. Right, so remember we want to get a 0 here. So in order to do that, I'm going to have to always use row 1. So we're going to say 2 row 1 minus row 2. Agreed? And then times at the side, so 2, 6 minus 2, 30. I think I've already given an example, I know I've already given an example of where I made a little whoopsie and missed a negative. So it's really easy if you see it to the side. Now, those Felix and Rian who were doing it without us? Do you mind not talking? So your choices are do it in silence if you're going ahead, or stay with us and ask a question, because it's quite disconcerting. 5 again. -2 take 1 is -3. 30 take 7, 23. It's very straightforward. Like, seriously, we're adding and timesing simple numbers. But you need to be concentrating, otherwise you're going to stuff up. Row 3, lovely. How are we going to do that one? How do we get a 0 here? Row 1, take row 2, and you know what? I think row 1, take row 3, sorry. I think we'll be quite okay that we don't actually have to do that one to the side, unless you want to. Because quite frankly, 1 take 1 is 0. 3 take 1 becomes 4. -1 take 2 is 1, and 15 take 0 is 15. Are we happy with that? Sorry, I just didn't realise if I was recording or not, but let's hope I have been. How am I going to get a 0, 0 here? Good. So we're going to go 4, row 2, and -5, row 3. Is everyone happy? We're just going, what's the number 5 and 4 both go into? Just like we did with simultaneous equations. If that was a 4 and a 10, I wouldn't then say 4 times 10 and go 40. I would, smaller one, go for 20, right? Always the smallest number that both of them go into. All right, so over here to the side, that's going to be 0 times everything through by 4. We get 20. We get -12. We get 92. 5. Last bit, that means that -17z equals 17, so z must be -1. We're going to slap that back into the one up here. So using row 2, that becomes 5y minus 3 times z. I'm not going to write -3z, right? You're going to do it yourself. What's -3 times -1? So it becomes +3. And then the dot dot is basically your addition. Get rid of the +3, take 3, so 5y equals 20. Therefore, y is 4. And you know what's coming. What do we do, Dave? Put it into the top one. So that's now going to be x plus 3y. Now, we've just said y is 4. So 3 times 4. So plus 12, take z, so -1 times -1 is +1, that equals 15. X has to be 2. So I'm about to go running from the room in fear of my life, because instead of doing all of that, why couldn't we just go to our calculators, all right, into equation, simultaneous. Instead of 2 unknowns, how many unknowns have we got now? 3. And I can actually put in, oops, where's mine? 1, 3 minus 1, 15. So 1, 3 minus 1, 15. 2, 1, 1, 7. Pop those in, we go solve. And we get our answers. So you've got that there. You've got that there to help. It'll also come up as, I think it says error or no solution for the other one we did. Why you are going to be practicing with this is, here comes, I'm running, is that you will eventually, so we're doing wordy ones. We're not going to do all of them. We'll just pick a few. But where we come into our own is when we have to do them with, oops, come on. You've got unknowns in there. Ooh, you really don't like it. So we're going to build up a little bit, practice with the numbers first, and then we'll get into these. Okay? So where do you find this? This is in your OneNote. It's called the 3 by 3. Oops. Oh, geez, I'm good. So we put, these were the things I was trying to show you with the planes, the different options. And as I said, that's just one application of these equations. We will talk a little bit more about when we've got no solution, no solution. So can we, what one shall we do? I think we've done 2 together. Shall we just practice you doing one yourself? How about we just do A? Go for it. So this is not essential. This is if you want to do it. If you don't want to do it, you can leave it out. So we've done. Some of you might go, I don't care for the minus. So what you can do is you can then multiply through by a negative. That is allowed. So if you want to, you could just go, that's 2 minus 1 and 7. And so you've timesed row 2 by minus 1. Agreed?
Is it positive 7 even without minus?
Oh, good Lord, it is. Sorry. I was going quick. Thanks. That's 2 errors. Pardon? Why did I times by negative? Only because now, most of the time I wouldn't bother doing that. I'm just saying if it upsets you that you have a negative here, by all means you can times through by the minus, but you do not have to. Shall we get rid of it? I'm assuming nobody else times through by the minus, so get rid of it. Okay, so we've got minus 2, we've got 1, we've got 7. I want to get a 0 here. So I'm going to have row 2, that's a minus, and we're going to subtract, or are we going to add? We're going to subtract 2, row 3. Agreed? 0, minus 2, 1, 7. We're going to times this through by 2, so I get 0, minus 2, 2, 12. And I'm subtracting because a minus take becomes a plus. So you get 0 minus 2 plus 2 is 0. 1 take 2 is minus 1. 7 take 12 is minus 5. So I've got 0, 0, minus 1, minus 5. Correct? I now have 1z equals minus 1z equals minus 5. Therefore, z equals 5. The reason we're doing these is to try and get practice when a number comes along. So we're now going to go into some of these ones where you have to make up the equations yourself. I mean, we're going to not bother with number 5. You might think it's deadly, but, you know, we make the number of managers X, clerks Y, labourers Z. So 2X plus 3Y plus 8Z will equal. And I would say 352. I wouldn't put all the zeros in there. Tristan, Arush, are we watching? I seem to be talking to the tops of heads a lot. Same with this one, it would be 1x plus 5y plus 4z equals 274, and away you go. So, irrelevant. Let's get some nice practice. What one shall we do? Let's do number 9. Uh-oh, I don't know what that's doing. But what we said was scroll down. Please scroll down to the other 3x3 matrices, and can you make sure that you do question 1A, B, C, D. Now what will happen is don't worry about the final answer, but some will end up being 0, 0, 0, 5, like the first example we did. Some might be all zeros, and then leave it and we'll deal with that on Monday. Awesome, thanks.